Hello, everyone, and welcome to the Tony Livins podcast. I am Tony Livins, and today we are going to explore one of the biggest breakthroughs in artificial intelligence, deep learning. It's a phrase you have probably heard many times. Every time someone talks about ChatGPT, self driving cars, facial recognition, image generation, or even voice assistants like Siri and Alexa, deep learning is usually working behind the scenes. But what exactly is deep learning? Why has it changed artificial intelligence so dramatically? And why do many people believe it's bringing us closer to human intelligence? Let's dive into it. To understand deep learning, we first need to understand why traditional machine learning wasn't enough. Imagine you wanted a computer to recognize a cat in a photograph. To a human, that's easy. Within a fraction of a second, you know it's a cat. You don't consciously think about ears, whiskers, eyes, or fur. Your brain simply recognizes it. But computers don't see images the way humans do. To a computer, an image is nothing more than a million of numbers representing pixels. So, how do you teach a computer what a cat looks like? Years ago, researchers had to manually tell the computer what features to look for. They would describe things like ear shape, eye position, fur texture, body proportions, and many other characteristics. This process worked reasonably well, but it had a major problem. Humans had to decide which features mattered, and humans don't always know. Now imagine trying to recognize not just cats, but every breed of dog, every type of car, every disease on an x ray, every handwritten digit, every face on Earth. This is where traditional machine learning started reaching its limits. Then came deep learning. Instead of telling the computer what features to look for, researchers asked a different question. What if the computer could discover the important features by itself? That simply transformed AI forever. Deep learning allows computers to learn directly from raw data. Instead of manually creating thousands of rules, the system studies millions of examples. Over time, it begins identifying patterns on its own. And that's incredibly powerful. Now let's talk about neural networks. You probably heard this term before. A neural network is the foundation of deep learning. The name comes from the human brain. Now, despite what many headlines suggest, a neural network is not a digital copy of the human brain. It's simply inspired by the idea that biological neurons are connected together. In artificial intelligence, we build mathematical versions of those connections, very simplified versions. A neural network has three basic parts. The first is the input layer. This is where information enters the system. If you're analyzing an image, the input is the pixel values. If you're analyzing medical records, the input could be age, blood pressure, heart rate, and other measurements. The second part is the hidden layers. This is where the real work happens. These layers process the information, searching for increasingly complex patterns. The more hidden layers we have, the deeper the network becomes. This is actually where the name deep learning comes from. Finally, we have the output layer. This produces the prediction. For example, this image is a cat. This transaction is fraudulent. This tumor is malignant. Or even the next word in this sentence is probably. Now, here's something fascinating. Imagine you are teaching a child to recognize faces. You don't explain every tiny detail, you simply show them thousands of faces. Eventually, they start to recognize faces naturally. Deep learning works in a similar way. The network improves through repeated exposure to data. Every example slightly adjusts the mathematical connections inside the model. Over time, the predictions become better and better. But here's the important point: the system is not understanding, it's learning statistical relationships. That distinction matters a lot because people often confuse impressive performance with genuine understanding. Now let's take image recognition as an example. The first hidden layer might learn to detect simple edges. The next layer might combine those edges into shapes. Another layer might identify eyes, nose, or ears. Later, layers combine everything together into complete objects. So instead of humans programming every feature, the system discovers them automatically. That's why deep learning became so successful. But this success comes with a cost. Deep learning requires enormous amounts of data. Thousands of examples usually aren't enough. Often we need millions, sometimes billions. And training these models require powerful computers with specialized hardware called GPUs. Without that computing power, many modern AI systems simply wouldn't exist. Now let's talk about something called the black box problem. This is one of the biggest challenges in modern AI. Imagine a doctor asks an AI whether a patient has cancer. The AI says yes. The obvious question becomes why? Sometimes the answer isn't clear. Even though the model produces highly accurate predictions, understanding exactly how it reached those conclusions can be extremely difficult. And that's a serious issue, especially in healthcare, finance, law, or autonomous vehicles. People deserve explanations, not just predictions. This is why explainable AI has become such an important research field. It's not enough for AI to be accurate. We also need AI to be understandable because trust comes from transparency. Now let's address one of the biggest misconceptions about deep learning. Many people believe that because these systems perform so well, they must be conscious. But performance is not conscious. A calculator performs arithmetic perfectly. That doesn't mean it understands mathematics. Similarly, a deep learning system can generate remarkably realistic language or images. But generating realistic output is not the same thing as experiencing reality. The model has no awareness, no emotions, no personal experiences, no understanding of what it means to exist. It simply recognizes patterns with extraordinary efficiency. And yet, that efficiency has changed the world. Deep learning now powers medical diagnosis. It helps detect diseases earlier than ever before. It translates languages almost instantly. It generates images, music, videos, and human like conversations. It assists scientists in discovering new medicines. It improves manufacturing, agriculture, finance, education. The list continues to grow. But every technological breakthrough raises new questions. If AI becomes increasingly capable, what skills become uniquely human? If machines become better at recognizing patterns, should humans focus more on creativity, judgment, ethics, critical thinking? Perhaps that's where our greatest value will remain. Deep learning has taught us something remarkable. Intelligence can emerge from incredibly simple mathematical operations repeated billions of times. That's both inspiring and humbling. But it also reminds us that intelligence alone isn't the full story. Humans bring something else. We bring purpose, meaning, experience, empathy, curiosity. We don't just process information, we interpret it. We give it context. We ask why. So, as deep learning continues transforming our world, maybe the most important question isn't how intelligent can machines become? Maybe it's how can humans use this technology wisely? Because every breakthrough in AI is also a reminder of the responsibility that comes with creating powerful tools. Thank you for listening to episode 9 of the Tony Levins podcast. If you enjoyed this episode, I really appreciate if you subscribed and shared it with someone interested in artificial intelligence and the future of technology.